All right, so here we're going to go through day 57. So let's start with problem 308. And it says Stacy wants to decorate the side of a cylindrical can. So a cylindrical can is a cylinder. That's a circular base, and then extend it up, similar to a prism. And look something like that. And using a rectangular piece of paper and wrapping it around the can. The paper is 21.3 centimeters by 27.5 centimeters. All right, so you can have it 21.3 by 27.5, something like that. So if you imagine this, we're taking a piece of paper and we will be wrapping it around to make a little tube around the cylinder, something like that. Okay. Which means that one of the dimensions of the paper is going to be the height of the cylinder, and then the other one, if it closes perfectly around, would form the circumference, right? The circumference of the base. So that means either 27.5 will be the base and 21.3 will be the height, if it's oriented this way, or if you orient it the other way, right, you could have one that's 27.5 centimeters tall and 21.3 will be your circumference, again in centimeters. Those are your two options. Now they said find the two possible diameters of the can that Stacy could use. So the diameter would be related, of those two, the height and the circumference, it would be related to the circumference. So it just matters which of them is the circumference. The way that I have it oriented here, that would be a 21.3 centimeter tall can that has a 27.5 centimeter circumference. So we know circumference is equal to pi times diameter. You could also write 2 times pi times the radius, but we're looking for the diameter here. Then in this case, we would say 27.5 equals pi times our diameter, and we'd have to solve for what the diameter is. Or if we did it this way, the way the purple one is oriented, then 21.3 is your circumference, 27.5 is your height. So that would be 21.3 equals pi times the diameter. In both of these cases, we just want to solve for d, the diameter. We could do that by dividing by pi on both sides, which would give us that the diameter is equal to 27.5 over pi. Take my calculator, I could just type in 27.5 divided by pi. It gives me 8.75352. If I round that to the nearest, say, hundredth, that'd be 8.75 centimeters, and they say approximately. All right, so that should be the bigger diameter. The other option, we divide 21.3 by pi to get d alone, and that would give us 21.3 divided by pi equals 6.78000005. So I could just round that to 6.78 centimeters. All right, those are our two possible diameters. And if you want to check it, just multiply it back by pi. Here we go. All right, it's mostly just about visualizing how this paper will wrap around that tube, that cylinder. All right, next we've got a wedge of cheese is 2 inches tall. So they give the height here is 2. The triangular base of the right prism has 2 9-inch edges. So it's an isosceles triangle for the base, which means that and that are the same. And it has a 4-inch edge. So the 4 inches it's talking about right there. Right, that's like the base of the triangle of the base. Several congruent wedges are arranged around a common 2-inch segment, as shown. How many wedges does it take to complete this wheel? So we're figuring the number of wedges to complete the wheel, and what is the volume of the wheel to the nearest cubic inch. It means when it's completed. So they only show 3 of them here. Now, some of my students did get confused when they saw that it's a wheel. They thought it meant it was a circle, but this is just made up of a bunch of triangles. So it's gonna be some polygon. We don't know how many sides yet. That's essentially what we're solving for in that first part of the question, how many wedges? So to know how many would fit around, we know that an entire wheel, the angles up here would add up to 360 degrees. So if we find what the angle is for one of these triangles, we can figure out how many would fit into 360 degrees. Now, to do that, I'm just going to redraw it. So we have a 9, 9, and 4 isosceles triangle like that. And now if we drop down an altitude, for an isosceles triangle, we know that an altitude will cut that base in half. So it's going to become 2 and 2. And now we could use inverse trig to figure out what this angle is up here. So this would be like theta over 2. We're trying to solve for actually what theta is. So we have the opposite and we have the hypotenuse. That would be sine, right? We know that sine of theta is equal to opposite over hypotenuse. In this case, it's theta over 2. So sine of whatever your angle is. Sine of theta over 2 in this case is equal to 2 over 9, right? That works because this is a right triangle. And now if we want to find what the theta over 2 is, we could do arc sine or inverse sine of both sides. So I'm going to write arc sine. I know that's how a lot of people's calculators say it. It could also say sine to the -1 power. That just means arc, or that means inverse sine, right? So sine gives you, if you put an angle into a sine function, it outputs the appropriate ratio of the sides. In this case, we have the ratio of the sides. We want to go backwards. We want to find what the angle is that would give that ratio of sides. So in this case, we use arc sine or inverse sine. So that would leave us with theta over 2 is equal to arc sine of 2/9. Type that in my calculator. On mine, it says sine to the -1. That's sine inverse. So sine inverse of 2/9 is 12.83, and I'm in degree mode. Do make sure you're in degree mode, but it is 12.83958841. So I'm not going to round that yet because our final answer is we're looking for theta. If I want to figure out what theta is, I'll multiply my theta over 2 by 2, which gives me 25.679176. All right, so we want to figure out how many of these would fit into 360 degrees, because that's our theta. So I will do 360 divided by theta, and in this case, I'm just going to store my theta in the calculator. So I'm pushing store A. So now whenever I use A, that's going to plug in, that's going to plug in this value of theta, not rounded. So I can do 360 divided by, and then I'll just click memvar A, and it gives me 14.019. Okay, so 14.019, which we would say, you're not going to put 1/100th or 2/100ths of a slice into it. So we'll round to the nearest whole number. That should be 14 wedges in a wheel. Okay. Now there will be a little bit of airspace there between the wheels, but it would be 14 full wedges can fit in there. Now if we want to find the volume of 14 wedges into the nearest cubic inch. Now you could use this value and just say you're going to put in a smaller bit of a wedge, but I'm just going to use the whole number 14. If you did that the other way, it would give you a different answer, but it will still be fine. But we just need to find the area of this. We have that the base is 4 of this triangle. We need to find the height of the triangle. You can do that using another trig function. In this case, we're going to use tangent. So we would know that tangent of theta over 2, which we still have theta over 2 saved right here, would be equal to 2, right? That's opposite, over adjacent. In this case, our adjacent is the height, what we're solving for. And now if you want to get the height alone, you'd multiply by height on both sides. And then we get height times tangent of theta over 2. And on this side, it's just 2. Then to get the height alone now, we have to divide by tangent of theta over 2 on both sides, giving us that the height is equal to 2 divided by the tangent of theta over 2. And again, we know what theta over 2 is. We can plug this value in from up here. So now I'm just going to write the area of one triangle. So one of these slices is equal to 1/2 times base times height, or you could write base times height over 2. It's the same thing. In this case, that means 1/2 times our base again is 4, right? Use the entire base. And our height we just wrote is 2 over tangent of theta over 2. So we can type that all in. And then once you have that, to find the area of the entire top, you would multiply it by, so the area of this 14-sided shape, it would just be 14 times the area of the triangle. Now, that is not what we're looking for, because we're looking for the volume of the entire wheel. And volume is 3D. We are just solving the area right here. Now, to find the volume of a prism, you just need the area of the base times the height. In this case, our height is 2. So we just multiply the area of the 14-sided thing. So the volume of the wheel is equal to the area of the base. In this case, it's this area of the 14-sided figure times the height. And again, the height we have, right? It's not this height. is going to be the height of the actual cheese. So we could say height of the wheel. So in this case, again, we said that would be 14 times the area of the triangle, which we have the area of the triangle right here. We can rewrite all of that. That'd be 1/2 times 4 times 2 over the tangent of theta over 2. We can rewrite from here, 12.839588841 times, again, the height of the wheel, we get that right there is 2. I can type all of this in, and that would give me the volume of the wheel. So I'm typing in 14 divided by 2, or times 1/2, times 4 times 2 divided by, and then you have to put parentheses so that this is all in the denominator. In my case, I wrote the tangent of, I had stored this value of theta as a, so I did tangent of a divided by 2. You could also type in tangent of 12.839. Make sure you use all of these digits here, even though that's way beyond the hundredths place, because you don't know how it's going to affect the final answer. Right, so I put that in, and then close the parenthesis for that tangent in the denominator. Make sure you close it the denominator, and then multiply it by 2. And make sure your 2 is not in the denominator. And that gives me that the volume of the cheese wheel is about equal to 491.39800057. They did not say what to round, to the nearest cubic inch. So if we round that to the nearest cubic inch, that'd be 491 inches cubed. And even if they hadn't told us that it was in cubic inches, we would know that because it's a 3D shape, right? Volume would be in 3 dimensions. Also, the area of the shape was in inches squared, and then we're multiplying it by the height. So it's inches squared times inches, which is inches cubed. So 491 inches cubed is our estimate for that one. All right, next we have pyramid TABCD, and it has a square base. So the way you draw that, just draw your square. ABCD is that base, so we would label it ABCD, like that. Those are your vertices down there. And then T must be the top part. So T will be up here. We can connect all of the other vertices to T. All right, so each side of ABCD is 20 centimeters. So we have 20 by 20 square. And the lateral edges that meet at T are 27 centimeters long. So lateral means side. You can think of like a lateral walk you might do when you're warming up, or lateral run. You can talk about like the lateral part of your body, that'd be your side. So the lateral edge, they're talking about this, right? That's one of the edges of it, and it's going up the side. And they say those are 27. Now that is not the same as the slant height, right? We were talking about the slant height with day 56. The slant height goes from this vertex down to the midpoint of the base there, right? Now you can see that that's actually more direct. This one's going at more of an angle. So if you want to find the slant height, you have to actually make a right triangle. But let's see what they're asking for first. It said make a diagram of TABCD showing F, where F is the point closest to T on ABCD. So that means if you're going straight down, right, the closest way to get from a point to a plane is to go directly down, right, at 90 degrees. So that's actually talking about the altitude. And that should be, I know I didn't draw that perfectly, it should be in the middle of the square, right? It should be in the middle of the base if it's actually a right prism, or right pyramid. So that's the altitude, which is, again, different from the slant height and different from the lateral edge. The lateral edge is the biggest, slant height should be the second longest, and then the shortest path is that altitude dropping straight down. So to find the altitude, we're going to actually need to first find the slant height. So it says to the nearest 0.1 centimeter, find the height TF. Now, let's see. To do that, we're going to have to use the Pythagorean theorem 2 different times. So first, you've got, right, this lateral edge there is 27. Now we know that it's a square pyramid. So when you drop down a slant height, or when you drop down the altitude, it's going to be cutting it in half. So instead of 20, we're going to use 10 for this leg here. And then what we're trying to find here is the slant height. I'll use S. I'll make sure it doesn't look like a 5. So we have a right angle there. You dropped down that slant height. Even though it's at an angle relative to the base, it still is making a 90-degree angle. So you can make this right triangle here. And that would give us 10 squared plus this, again, slant height. So it's this angle right, or this side right here, squared, is equal to 27 squared, the hypotenuse squared. Now we know 10 squared is 100 plus s squared equals 27 squared is 729. So that means that we could subtract 100 from both sides and we get that s squared is equal to 629. Now if you want to solve for just s, just the slant height, you would say it's the square root of 629. You could also just stop here because if you know what you're going to do next, you actually will need the slant height squared, not the slant height. So this is technically an unnecessary step. But next we have to do this right triangle here. So using the altitude and connecting that altitude to the slant height. Right now we know what the slant height is. So we have this. This will also be a right angle because the altitude we know meets the base at a right angle. So in this case we have our altitude, which is what we're trying to find. I'll call that h for height. We have, again, it will be 10 because you're still cutting this 20 base in half, just the other way now. And now we have our slant height as the hypotenuse, which again we know is the square root of 629. So now we want to solve for h. We'll set up another Pythagorean theorem. In this case, it will be 10 squared plus the height squared, or the altitude squared, is equal to the slant height squared. Again, like I said, we know what the slant height squared is. You could plug in the square root of 629. Right? The square root squared cancels out, so that would still end up with 629. Or you could just say the slant height squared down here is 629. And we know 10 squared is 100. So 100 plus h squared equals 629. Subtract 100 from both sides. That gives us that h squared is equal to 529. Now, because it's geometry, you don't have to worry about your negative solution. You can just do the square root of both sides. The square root of 529 is actually 23. You can type that in your calculator to verify, but that is our altitude. And they say to the nearest 0.1 centimeter. Technically, we don't need to round it here. So you could say 23.0. But it is exactly 23 using this information. But they say find the volume of TABCD to the nearest centimeter cubed. Okay, so for this one, you'd actually probably have to round. What we're going to need to do is find the area of the base, multiply it by the height, and then multiply that by 1/3. Because we know the volume of a pyramid is equal to the base, and I'm doing a capital B because I mean like the area of this base, in this case it's that square, times the height times 1/3. Right, so it's like the volume of a prism, but then you have to multiply by 1/3. You could think of that as dividing it by 3. So in this case, we know that our base is that square, so that's 20 by 20. Our height we just solved for is 23, and the 1/3, plug that in. So we could write 1/3 times basically 400 times 23, which gives us 3,066.66666, right? It keeps going like that. They said round it to the nearest centimeter cubed, in this case for volume. So we'd say our volume is about equal to 3,066, to the nearest centimeter cubed. Round that up to 3,067 centimeters cubed. And I guess for the height, again, you should include your units. It's 23 centimeters. So that would be how you would do that one. Again, they did say to the nearest 1/10 of a centimeter for this, so maybe you'd say the height equals 23.0 centimeters, but this is actually not a rounded value. This height here happened to work out perfectly. All right, continuation. Find the slant height of the pyramid ABCD. The slant height is the height of the lateral face. So we actually already did that, right? That'd be square root of 629. So it's equal to the square root of 629 centimeters. 629 is not a perfect square, so I'm just going to type that into my calculator. The square root of 629 gives me 25.079874241. Did they say what to round it to? They did not. Okay, well, that would be maybe round it to the nearest 100th, just to be safe. Okay, and that would be your slant height. Okay, again, that slant height is talking about going from that top vertex directly to the midpoint of one of the edges of the base. Right, so it could be there, could be there, could be there. Right, those should all be the same. It should be shorter than the 27, right, the lateral edge, but also should be longer than the altitude. All right, so that's how you would do those ones. I'm not sure why they asked it in that order, but just so we have them all. And then next, they say, what is the minimum amount of wrapping paper needed to wrap a box with dimensions 20 centimeters by 10 centimeters by 30 centimeters? So in this case, they're not looking for volume, right? If you're wrapping paper around it, Now, in reality, you're going to need a little bit more than what actually covers the surface of it because you have to tape it down and whatnot. But I guess if they're saying the minimum amount, I mean, just to cover it, maybe it's like special wrapping paper that just you put it on the faces and you don't even have to tape it down, or you find a way to tape it that doesn't involve any level of overlap. Right? So we have a 20 by 10 by 30, and you could draw it. Right? You don't have to draw the faces the way that I did them there. Maybe it looks something like this. Okay. Now we know that for a rectangular prism, like this box, right? A box is a rectangular prism. You're gonna have 6 faces, just like on a cube. The way you can do that is you can do that for any shape quickly in your head by doing the number of sides of the base. In this case, it's 4 plus the top plus the bottom, so plus 2. Right? If you had a 10-sided shape and you made a prism out of it, then it would have 10 faces plus a top face plus a bottom face is 12 faces. Right? So again, it's just the number of edges in one face plus 2. So we have 6 faces, and in this case, 2 of them will be 10 by 30. Right? So that would be like this face and the back face there. 2 of them will be 20 by 30. Right? So in this case, that'd be like that, and this back one there. And then 2 of them will be 20 by 10. Right? So that would be here and here. Each edge length will match up with each of the other 2 edge lengths twice. So we'll multiply each of these by 2. So 2 times 10 times 30 plus 2 times 20 times 30 plus 2 times 20 times 10 will be our surface area. And again, it's going to be, all of those are in centimeters, so they'll look at a centimeter squared. 2 times 10 is 20. 20 times 30 gives us 600 plus 20 times 30 is 600 times 2 would be 1200 plus 20 times 10 is 200 times 2 is 400. All right, so we're getting 600 plus 1200 plus 400. 600 and 400 make 1,000. So we get 1,000 plus 1200 is 2,200. Our surface area, again, the units are centimeters. And even though it is going around a 3D shape, area is 2 dimensions. So it's going to be centimeters squared. You can also think of each of these as centimeters times centimeters, centimeters times centimeters is centimeters squared. All right, so that would be the surface area if you just put the wrapping paper so it's covering those faces with no overlap. All right, so that would be how you would do that one. Most of the questions had more to do with volume. But yeah, surface area is similar. Again, if you have to calculate a surface area, just find the area of each of the faces, right? So don't forget the top and the bottom face. If it's in this case, it was a rectangular prism, so they were all rectangles. But say you had a different shape, like a decagon or something, then you would have to find the area of that base, right? Using the same kind of strategy we did for the wheel, right? You have to find the angle, you have to use the angle to use trig to find the base and the height, divide it into triangles. So find that base, you'd have to multiply that by 2 because you'll have one base on bottom, one base on top, and then everything else for a prism should be rectangles. So you just find that by multiplying the edge length of the base times the height, and then figure out how many rectangles there are around. So that's all you have to do for surface area. If you have any questions on any of these, feel free to leave a comment below. All right, well, thank you so much.